All right. I think we're through. Hi, everyone. Can you hear me? If you can, please type the fourth digit of pi. And that's how I'll be able to know that you could hear me. Because if you just started typing pi, how would I know? It might just be because you like today. So let's see. Can you guys hear me? Doesn't seem like it. Oh, something's coming out. The fourth digit of pi, 3.1314. Ah, okay. I think we got it. Does the three count? That's a good question, but I think we're through. All right. Well, hello, everybody. It's nice to see you all. I'm Po Shen Lo, and welcome to our YouTube channel and our live stream. I'm not really in a good place to do the live stream right now because I am in an airport. I'm on my way to San Francisco because, in fact, I'm giving some talks tomorrow in San Francisco and the next day in New Jersey. However, you're in luck because we have some incredible hosts for tonight's live stream. Tonight's live stream is, in fact, an official collaboration with Math Kangaroo USA. We love Math Kangaroo problems because, well, they are quite creative. I've seen a lot of math contest problems and the whole scope of math contests. In fact, what I'm speaking at tomorrow morning is a math contest. But we are always happy to discuss Math Kangaroo problems because they go through a very long period of review to create very creative things. And today, the focus is the best of live solved. So these are some of our favorite questions. We are also in luck because we have a special guest today. We have Joanna Matheson, who happens to be the leader of Math Kangaroo USA, and she has a few words to share with all of you. Joanna, do you want to jump in?
Thank you, Paul, so much. Hello, everyone. Good evening. I'm so excited to be here today on the Daily Challenge Show. And this show is truly amazing, as Math Kangaroo questions are great, but this show is really one of a kind. It's not just about problem solving, but creating thinking and collaborating with others. But today isn't just any day. It's March 14th. It's Pi Day, a day dedicated to celebrating one of the most famous mathematical constants, pi, the never-ending irrational number. Have you all done anything special to celebrate Pi Day today? I know some people do like bring pies to school, or they do some circular object counting or things like that. Wonderful. And I have a question. How many digits did you memorize after the decimal point? 3 points. And how far did you go with your memorization? Pretty good. Look at this. Wow, we have pretty smart people here. I remember at one of the schools here in the neighborhood, there was a contest, how many digits you can memorize, and the winner get to win a pie and take it home with his family, which was, I think it's a great gift. And also I heard, and tell me if I'm right, that the winner of the pi memorization digits is the one that's talked about the digit or memorized all the digits and who could speak for 11 hours straight. So I would never take this challenge, but maybe some people do. So wonderful. Thank you for sharing all your memorization gifts. And the big day of Math Kangaroo is here, not just Pi, but also Math Kangaroo. Next week on Thursday, we're starting our competition, and we already have more than 54,000 students enrolled, which is a great success. And I just have another question for you. Are you signed up for Math Kangaroo? And what are you one of the 54,000 students? If you could tell me yes or no. Let's see. Lots of yeses. Awesome. That's wonderful. That's great. Yeah, so registration is closed, but we have amazing things prepared for you, very creative questions. And maybe, Paul, maybe we can do a show maybe in May or June, of the questions, right, that we did in 2025, which is next week, which would be amazing. And I hope everyone here today have some ideas about Math Kangaroo competition questions. If not, you will very soon learn more. And before I go, I have a very exciting news. Since today is this very special Pi Day, and to celebrate mathematics, Math Kangaroo and Pi Day, we have a surprise. So at the end of the show, we will select three students, uh, randomly selected, to win three prizes. And I can show you what I have here. I have one student will get this kangaroo, plush kangaroo. The second winner will get Math Kangaroo playing cards. And the third winner will get Math Kangaroo puzzles. Actually, Lego puzzles. So you can basically put together a kangaroo out of the puzzle too. So please stay till the end to get the nice gifts. And I think that show will be amazing as always. So stick around, enjoy the challenge, and see if you're one of the lucky winners tonight. And Paul, I send it back to you.
Wonderful, wonderful. Okay, well, thank you very much, Joanna. It's actually real fun to have the leader of the entire event in the USA here with us. You're 50,000 plus people. That's huge. That's at the size of any massive math contest in the United States. So congratulations. Again, I think a lot of the people who follow our channel and who are in this series of live solves, perhaps you're signing up because you saw that the questions are good. I don't know what the questions are yet. Obviously, I shouldn't know anyway because I'm not part of the ones making them, but I'm sure they're going to be interesting. Well, with that, I'm going to pass it off in a moment to my co-host. And I also want to make one more comment. You probably noticed by now that there's this chat here. And you notice that some people are having a lot of fun in the chat. If you don't know how to use the chat, let me tell you. Oh my gosh. I think what happened is that somebody actually typed out all these digits of pi that they know, and it took a while. Oh wow, well done. But in any case, the chat, the way you use it, you send messages to chat relay. So when you're sending messages to chat, choose who to send in the drop-down menu, choose chat relay. You might notice that when you send messages, they don't all go through. That's because there's a limit of how many messages can appear every second. We do that so it doesn't go nuts. If you say something that's particularly exciting or good, well, you might get a star. That's what those are about. And then the more stars you have, the more likely the next messages you say go through. If you say something not so good, unfortunately, our moderators might cut it out, and that'll reduce the chance that you get through next time. Regardless, it's time to really start. And you're in luck because we have Melody and Ryan. Melody and Ryan, why don't you take it off from here?
4159, this is pi, followed by 2653589, circumference over diameter 79, then 323. OMG, can't you see? 8462643, and now we're on a spree. 38 and 32, now we're blue.
This Pi song is playing in the background. So this A could be anywhere on this line, actually. So we have to make sure that the areas will still be the same if A was over here or something. But I don't think we have to worry about it. We know a very handy formula for the area of a triangle. Let's write it down here. A triangle is 1/2 base times height. And we get that formula from base times height is just the area of the rectangle that it doesn't completely fill out. So the height of any triangle, or the area of any triangle, is half of the same rectangle, I guess. This triangle has base length here and height this tall. And the rectangle that it's in, this portion, is twice the area. So if we know that the sum of the area of this triangle and this triangle is 10, then we know that the sum of this rectangle and this rectangle is 10 times 2, which is 20 centimeters squared, which a lot of you are saying in the chat, so good job. I'm pretty confident that this is the right answer, especially since all of you guys think so too. So let's check. Yes, it is 20. Perfect.
Great. All right. Looks like I have next question. Okay, some diagrams here now. In which of the four squares is the ratio of the black area to the white area the largest? So we need to find the area of all the black tiles to the area of all the white tiles inside this larger square. If we want to maximize the ratio of the black area to the white area, first of all of the areas seem to be the same because they're all the same size square. So what we're really looking for is when we divide the black area by the white area, we should get the biggest number possible. Now we know that the black and the white area have to add up to the same number for all of them because all the square sizes are the same. So essentially, this is the same thing as maximizing just the black area. Because if you maximize the black area, then the white area will automatically decrease with it. So if we take a look at all four of these, this first one has 1/4 of it shaded in white, which means that the remaining black area is 3/4 of the square. This one over here is split into a total of 8 equal parts, of which 6 of them are black, which means that the black area is 6/8 or 3/4. This one here looks a little trickier, but what we have to notice is these little triangles is the same as one of these smaller squares. So if we can count up the number of little triangles here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I think I counted that right. We have 16 little triangles here, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of them are black. So that gives us 12 over 16, which is 3/4. And for our last one, we again have two triangles and then also, so it's the same setup as the one that we just did before, except they're shaded in different now. But we can still see that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 black triangles. So that's again 12 over 16, which gives us 3/4. That means that all of them have the same ratio of black area to white area because all of the black tiles make up the same fraction of the total square tile. It looks like everyone is also getting E, so that's great. And just to check it, yes, it is E.
Very nice question. I'm always skeptical when there's like an answer choice that's all of the above or none of the above. But this one turned out really well. I really like this next question because it's about a kangaroo family. Who doesn't like that? But a father kangaroo lives with 3 children. And the way their voting system works is however many years old you are is however many votes you get. Right now, the father is 36 years old and the children are 13, 6, and 4 years old. So if you add that up, no matter what, whatever the father wants, he'll get. But we want to know how many years will it take for the children to have the majority of the votes if they all vote the same way? Let's call the number of years that have to pass X. After X years, the children could finally win a vote. So after X years, the father will get 36 plus X votes. And then the children will get 13 plus 6 plus 4 plus X. Oh, not X. They each get X more votes. So there's 3 X's. So plus 3X. And we want to make sure that the children get more votes than the father. So we're going to put a less than symbol there. Let's just work with this as if it's an equation. The only time you have to be worried about an inequality symbol here is if you multiply or divide by a negative number. And I don't think we have to worry about that right now. So let's subtract X from both sides and carry on like this. Oh, I'll also move all the numbers to this side. So it will be 36 minus 13 plus 6 plus 4 altogether, which is 23. So 36 minus 23 is less than 2x. And that means 13 is less than 2x. So 13 over 2 is less than x. And we need an integer number of years. 13 over 2 is 6.5. So we need the integer number of years to be greater than 6.5. And the smallest one we have is 7, which is answer choice C. And I see a lot of you are saying that it's C. So let's check our answer. Yes, it is. Perfect.
Yeah, great question. Having to use variables as well and setting up inequalities. Fun stuff. But in this one, we have 2 girls named Eva and Olga, and 3 boys, Adam, Isaac, and Urban, playing with a ball. And when the girl has a ball, she throws it to the other girl or to another boy. When a boy has a ball, he throws it to another boy, but never the boy from whom he just received it. So Eva starts by throwing the ball to Adam. Who will do the 5th throw? Or maybe we should make some sort of diagram here. Let's say we have Eva, Olga, Adam, Isaac, Urban. All right, so we're told that we start off with Eva throwing the ball to Adam. This way. And then also, we should probably note that Eva and Olga are girls. And then Adam, Isaac, and Urban are boys. All right, so Eva throws it to Adam. Now, Adam has to throw it to another boy, but not the boy he just received it from. But he received it from a girl, so he can throw it to either of the boys. So he could go to either Isaac or he could go to Urban. So we have 2 choices actually, which is really interesting. We can either go to Isaac or we can go to Urban. Now, no matter which, well, if it goes to Urban now, Urban has to throw it to another boy, but not who he just received it from. So if Urban gets it, then he can't throw it back to Adam, but he can give it to Isaac. On the other hand, if Isaac got it, then Isaac can't throw it back to Adam, but gives it to Urban instead. All right, so this is getting a little complicated, but right now we are at a total of one throw, our second throw, which can go either to Urban or Isaac, and our third throw, which basically just swaps between Urban or Isaac depending on who has the ball. Now, whoever has the ball from Urban or Isaac can't throw it to the other person because they just got it from them, but they can throw it to Adam because Adam just also hasn't thrown Urban or Isaac the ball. So, no matter who has it, it'll eventually go to Adam. And then, since that was 4 throws now, the ball is in Adam's hands, and Adam now has opportunity to make the 5th throw. So it doesn't matter who Adam throws it to now, but just the fact that he is going to do the 5th throw is what we're looking for. So the answer here is going to be option A. So let's take a look again. And yes, it was option A. All right, so that one was a little complicated and a lot of arrows going on here, but really it's just understanding who you can throw it to. And eventually we found out in the end that it comes back to Adam for the 5th throw.
Yeah, for questions like that that seem kind of open-ended, I think you kind of have to just choose one path because it should always end up with the same answer, and you don't have to worry about all the other paths. And now we have another geometry question. Square ABCD has sides with lengths equal to 3 centimeters. Points M and N lie on A, D, and AB such that CM and CN split the square into 3 pieces of the same area. So what is the length of DM? First, let's label the sides of the square. We know that the sides are 3 centimeters, so I'll just put 3's here so we remember that. I think an important thing to notice is that DM and NB are the same length because we know that this area and this area are the same and they have the same one leg, so they have to have the same other one. So let's call that X. Let's start by finding what the areas are. We know that the top triangle has to be 3x over 2 because it's 1/2 base times height. And so is this triangle on the right, also 3x over 2. This middle shape is a little bit trickier, but I think we can just do a little clever subtraction. We know that the total area is 9 because 3 times 3 is 9. And this middle space is just everything that's not these two. So the total area is 9. And then the two triangles over here have a total area of 3x because there's 3x over 2 plus 3x over 2, which is just 3x. So let's label this 9 minus 3x. And we're told that all of the areas have the same area. So we know that 3x over 2 equals 9 minus 3x. And we can just solve that like an equation. 3x equals 18 minus 6x. Here I just multiplied both sides by 2. Multiply this by 2, you get 3x. Multiply each of these terms by 2, you get 18 minus 6x. And you can move 6x to the other side and get 9x equals 18. So x equals 2. And x is exactly what we want because we wanted the length of dm. So the answer should be 2 centimeters. Let's check it. Oh. Yes, it is 2 centimeters. Perfect.
Yeah, always the geometry problems sometimes take us some time to realize what they're looking for and what information we can use at the end. It was some so the simple formulas were finding area of a triangle, seeing what angles you have to use that and solve the problems. All right. Ooh, interesting question here. We have Martha multiply two two-digit numbers correctly on a piece of paper. Then she scribbled out three of the digits as shown. What is the sum of the digits she scribbled out? All right, so immediately what I'm noticing here is we're multiplying two two-digit numbers and we're getting a three-digit number as our answer. Let's look at the units digit first, because whenever we multiply and stack two numbers, so let's say we have some number 3, and then we're going to multiply by 2, some number. Multiplying this by this will give us some number with a units digit. And we know that our units digit in this case is 2. So whatever this number is multiplied by 3 has to give us a units digit of 2. Now, 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9, but 4 times 3 is 12. So if this number was a 4 here, we would have 4 times 3 is 12, which would make us put a 2 here and carry over a 1. But that tells us the units digit is going to be 2, which is exactly what we're looking for. So 4 is this number right here. Next, we want to know what our next numbers are going to be. So we can continue multiplying. We know that this 4, we're going to multiply with this. Whatever, let's call this x since we only have one number left. We're going to get 4 times x, but then we're going to have to add the 1 that we had to carry over. So it's going to be 4x plus 1. Now moving on to the other one, now we multiply the 2 by the 3 and this x. This 1 carryover doesn't matter anymore. We put a 0 first, and then multiply the 2 by the 3 to get 6, and then the 2 by the x to get our leading digits. Okay. So what I'm noticing here is now we know that 2x is going to be the number that we have in front. Seems like kind of an interesting question now, but if this digit is going to be a 4 here, we know that this number is going to be in the 300s. So we could try guessing and checking a couple numbers. In fact, we know that 24 times some number ending in a 3 should be around another like less than 20 even. Maybe 24 times 13, because we know that 20 times 20 is 400. Let's try that. 13 times 24. Multiply it, we get 2, 1, 5, 0, 6, 2. We get 2, 1, 3. And we see that the 3 and the 2 both match up from here and here. And that means that this number here is going to be a 1. This number is also going to be a 1. So it's asking what the sum of the 3 digits that she scribbled out is. That's just 1 plus 4 plus 1, which is equal to 6. All right. So we had to make a couple of educated guesses here, but let's see if our answer is correct. Yes, it is 6. All right, great job.
What I really like about that question is it was really tough getting to the answer, but once you got it, you can always just multiply those two numbers to check that it's right. And it was right. So that was great. Oh, this next one is kind of a logic question. It's not just restricted to math. Math is very logical, very important. So a lion is hidden in one of 3 rooms. A note on door 1 says the lion is here. A note on door 2 says the lion is not here. And a note on door 3 says that 2 plus 3 equals 2 times 3. And only one of these sentences is true. So we need to find which room the lion is in. Let's draw our doors out just because I think it might be easier to visualize this way. So these are our 3 doors. And the one thing we know for sure is that 2 plus 3 is not 2 times 3. So we know that the sign on door 3 is a lie, not the true. So I'll just write false. So out of door 1 and door 2, one of those must be true. Let's just assume that the sign on door 1 is true. The lion is here. So the lion is here. Let's check door 2. The lion is not here. Well, if the lion is here, then the lion is not here, which means that both of these doors are true. But it can't be because we're told that only one sentence is true. So the lion can't be here. Let's say the lion's here. Let's double check our door 1. The lion is here. No, it's not here. The lion is not here, but it is there. So both of these are false. And this can never be true. So the lion is not behind door 2. Let's say that the lion's behind door 3. We'll check sentence 1. The lion is here. The lion is not here, so that's false. Sentence 2 says the lion is not here, and that's true. The lion is not behind door 2, it's behind door 3. So then that makes sentence 2 true. So the lion must be in door 3 because the conditions aren't satisfied anywhere else. So it is C. It's in room 3. And a lot of you are spamming C, so I'm pretty certain that we're right. Yes, it is. Perfect.
Yeah, that was a really amazing question. When we think about math, we always think about all the calculations, but some of the logic questions are really interesting to try and solve. It's nothing short of interesting. Okay, let's move on to our next question here. Ooh, okay. Looks like we have another diagram. It shows a rectangle with dimensions of 11 by 7 containing 2 circles. Each circle touches 3 of the sides between the rectangle. What is the distance between the centers of the 2 circles? All right. So we have 2 circles here. Now, they're probably roughly centered around here, and we're trying to find the distance between those 2 centers. Now, we know that the radius of the circle is this distance right here, from the center to a point on the circle. Now, coincidentally, that radius seems to also be half of the height of the rectangle, or in this case, 7 over 2. So, this center is around 7 halves of the way along the length of the rectangle. This center right over here, we can say the same thing about it. It has the same radius as the first circle, so this one is going to be 7 halves of the way along from the right side. Now, if it's 7 halves of the way along from the right side, and this is 7 halves of the way along from the left side, the distance between them can be calculated by finding 11, which is the total length of the rectangle, minus 7 halves, which is the left side, minus another 7 halves for the little right side right here. And we get it's equal to 4. So the distance between these 2 centers would be 4. And looks like we have a couple of mixed answers, but we're starting to get 4s in the chat. But let's see. Maybe I did something wrong. Ooh, okay. So the answer was 4. Great. So now we're seeing a lot of people that are getting option 4. That's great to see.
Right. Very nice circle question. I really like the geometry questions in this contest. They're really fun. Oh, it looks like a geometry question, kind of. It says there's a rectangle. Okay, a rectangle is divided into 40 identical squares. The rectangle contains more than one row of squares. And Andrew found the middle row of squares and colored it in. How many squares did he not color? This is kind of like what I was talking about in a previous question. You may think it's a rectangle with 40 identical squares. There are so many ways to do it. If it doesn't specify, we can just figure out one way to do it and then see how that goes. And just a spoiler alert, I think there really is only one way to do it, but let's just see how it goes. So immediately we know that 40 is 5 times 8. And so we can just pretend that we have 5 squares by 8 squares, like there are 5 rows and 8 columns. And so the middle row would be the third row. And that row, like all the other rows, also have 8 squares in it. So we know that Andrew colors in 8 squares, which means he did not color in 40 minus 8 squares, which is 32. And I think that should just be our answer. We can try to visualize this more maybe, because it tells us that there's more than one row of squares, which means it can't be a 1 by 40 rectangle. So it has to be a 5 by 8. And you can't have a middle row if there are 8 rows, because that's an even number. So I think we're right. It should be 32. Yes, it is.
Yeah, great. Yeah, another really interesting question, especially having to understand that not any type of square will work. Like a 40 by 1 or a 2 by 20 won't work. It has to be a 5 by 8. So, a lot of elimination there with that problem. All right, onwards with the next one. Ooh, okay. We have a hotel on a island in the Caribbean that advertises by using the slogan 350 days of sun every year. According to this ad, what is the smallest number of days Willie Byrne has to stay at the hotel in 2018 to be certain of having 2 consecutive days of sun? Hmm. Okay. Seems like a really interesting question, but we can kind of think about it as what's the most number of days he will have to stay, or what's the smallest number of days to be certain for having 2 consecutive days of sun? So essentially, we're trying to find like a worst case scenario in this. If we had to space out our days of sun every year with our days of no sun, how can we do it in such a way such that you won't get 2 consecutive days until the most like latest day possible? So off the top of my head, one way that I'm thinking about it is if we have one day of sun and one day of no sun, and then another day of sun, and then another day of no sun, and sun, and then keep on going until we have no more no sun days left. So in that case, we would have, first of all, there's 365 days in a year, minus 350. That's 15 no sun days. So we would have a row of 15 Sundays and 15 no Sundays for a total of 30, and we would end on a no Sunday. But then we would have to have 2 more Sundays at the end to get the 2 consecutive days of sun that the question is asking for. And that would give us a total of 30 from all of these plus 2, which gives us 32 consecutive days that you need to stay to be certain that you will see 2 consecutive days of sun. Now, let's take a look at that. And yes, the answer is 32. All right, great. Looks like a lot of people are getting D in the chat as well, which is great to see.
That was like another logic problem. I like those the best. Oh, here, this one looks kind of complicated. Let's see what it says. Cindy colors each region of the pattern shown to the right, red, blue, or yellow. She colors regions that touch each other different colors, and she colors the outer region blue. How many regions of the completed pattern are colored blue? Luckily, I have a blue colored thing here, so hopefully it shows up. So we know that this thing, oh, I'm very bad at coloring, so maybe we can't use this strategy. But this outer thing is blue. We know that for sure. And it doesn't really matter if we choose red or yellow next. We just know that it's not blue. But let's say that this part is yellow and this part is red. I'm not sure if this contest allows colors actually, but you can just label them R, B, and Y, and it works the same. And then the next one, we can look here and see that the red touches this region and the yellow also touches that region. So it has to be blue as well. So let's make this part blue. And you can kind of just keep going inwards. Let's find our yellow region again. This region, I did not switch that color. This region has to be yellow. And this region has to be red. And this one has to be blue. And this middle one has to be yellow too, but we don't really care. We just know it's not blue. And this entire time we colored the outer region blue, this kind of middle-ish region blue, and this very middle region blue. So we used 3 blues. And I think that's all the question is asking for. How many regions of the completed pattern are colored blue? So our answer should be 3. B, just like a lot of you are saying in the chat. Yes, it is. Okay.
Amazing. Yeah, that question was also really interesting too, because you could color out and solve it, but at the beginning, there were 2 ways to go. Once you had the first one colored blue, you could either color the left one yellow or you could color it red. But the neat part about the question was, no matter which way you did it, you would get the same answer. All right. Okay, we have another diagram here. We have 3 small squares that are drawn inside of a larger square, as shown. What is the length of the line marked with a question mark? All right. So we know that the whole length of this is 28 centimeters. Since the larger square is also 28 centimeters, we know that the height of this bigger shape is also 28 centimeters. Now, each of these individual squares, we can calculate the side length of it by knowing that this full height here, full height of the big square is 28 centimeters. And since they give us some of these numbers, that means that a side length of this square will be 28 minus 22, which is 6. Side length of this one, we don't know yet, but the last one here would be 28 minus 13, which is, or 20 minus 15, which is 13. That tells us that these lengths also here are 6 and 13 because they're squares. Now, we know that this whole length here has to add to 28 centimeters. Right now, we have 6 centimeters and 13 centimeters. So to find this missing side length here, 28 minus 6 minus 13, we get 9. And so that side length is 9. That also means that the height of this square, the middle one, is going to be 9 as well. Now, since we know that the whole side length of this larger square is 28, and this little side length is 9, then this missing part has to be 28 minus 9, or 19. So the option that is correct should be option E. and we're getting a lot of ease in the chat as well. So I also feel pretty confident, but just to make sure, yes, option E, 19 centimeters.
That was a nice question. Oh, here we have one that requires a bit of imagination. Maybe on the real contest, if you get scratch paper, you can actually try folding it and see if it helps you imagine what's going on here. So Zaida took a square piece of paper and folded two of its sides to the diagonal as shown to obtain a quadrilateral. What is the size of the largest angle of the quadrilateral? I think this means that you kind of fold it so that this side lies on this diagonal. So if you fold it onto the diagonal, you know that this angle is split into two, perfectly in half, actually. So let me draw that, try to draw that at least. So this blue line I just drew is basically this thing that we have right here. That's the edge of our new shape. And since we know that split perfectly in half, this is 45 degrees, and this is also 45 degrees. Let's draw this white diagonal onto our new shape. That would be this blue line that I just drew. And so we know that this angle is 45 degrees. Oh, sorry, that is not 45 degrees. What was I doing? This whole thing is 45 degrees. So those smaller ones are half of 45 degrees, which is 22.5. I'm actually not sure how to erase this. Let's see. Okay, 22.5 and 22.5. And this whole thing is 45 because we know that an angle of a square is 90. So then this diagonal also perfectly divides that in half. Okay, so this is 22.5 degrees. And let's look at this triangle here. We know that this angle is also 45 degrees because it was just like this top angle here. And a triangle has 180 degrees in total. So let's call this missing angle X. We know that 22.5 plus 45 plus X equals 180 degrees. So we can solve for X. X equals 180 minus 45 minus 22.5. Let's break this down a little bit. X equals 135 minus 22.5. So X equals 112.5 degrees. And that's one of our answer choices. So let's see if it's the right one. Yes, it is.
Wow, really amazing question here. And that took like a lot of thinking also because you had to visualize folding over the paper and getting this new shape and what these angles mean compared to the last shape and really just really conceptual and thinking question also. Let's move on to the next one though. The next one is how many times do we have to roll a regular dice to be sure that at least one result will be repeated? Okay, so this seems like kind of the last question, right? Or the last question that I did, or two questions ago, where we kind of have to find the worst case scenario here. First of all, you know that a regular die has six sides. These are labeled 1, 2, 3, 4, 5, and 6. How many times do we have to roll a regular die to be sure that at least one result will be repeated? Essentially, we want to find the maximum number of times that we can roll the die and get a different number each time first, and then go from there. Well, to get a different number of die, we can simply just do this. we can get a 1 on our first roll, 2 on our second roll, and so on and so forth, and a different number on each of the first 6 rolls. Then the 7th roll, we have to get one of these 6 numbers. So if we get any of them, then automatically that becomes a repeat, which means that it is possible to get no repeats in the first 6 rolls, but after 7 rolls, you're guaranteed to have a repeat. And that is exactly what the answer is as well. C, 7 rolls.
Oh, perfect. I think we have time for one more question, hopefully. We'll go really fast, guys, I promise. A game consists of dropping a ball from the top of a board with rows of pins as shown in the picture. The ball bounces either to the right or to the left each time it hits a pin. One possible route for the ball to take is shown below. It's kind of hard to see, but it goes from this pin to this pin all the way down to B. And how many possible different routes can a ball take to get to bin B? We can see that the answer choice numbers are pretty low, so I think we can just count them all. It's probably easier than trying to calculate it. The first one I see is it could just go all the way down this row. I'll draw it out. You can just go down this way and get into B. That was very sketchy, I'm sorry. Or we could go almost all the way down this way, but then go right on the second to last pin, but then end up going left on the last one. So more of like that. Or we could follow the path it already gave us. I think there's only one other thing we could do, and that's to not go left at the top pin at all. We have to go right, and then just go down this way. And I don't think we have any other choices, because if we went right even one more, then there's no way to go back to bin B. So I think our answer is just C, which is 4. And a lot of you are saying that in the chat too, so I believe it. But yes, it is 4. Perfect.
Yeah, that was really another amazing question. Having to draw it out sometimes also really helps. All right, we have 2 minutes left, but I think we can speed through one more question in the spirit of Pi Day. So Ria wants to write a number in every cell of this border of a 6x5 table in each cell. The number she writes is equal to the sum of the 2 numbers in the cells with which this cell shares an edge. 2 numbers are given in the diagram. What number will she write in the cell marked X? Okay, so we're putting a number in each one of these squares, and in each cell, the number has to be equal to the sum of the 2 numbers in the cells with which this cell shares an edge with. Right, really interesting question here. Now, we know we're going to have 2 numbers that add to 10 next to 10. So in this spot and this spot. Eventually, we're also going to have to go down the line and get a 3 for our last spot here. Seems like a really interesting question. I mean, we can start off by trying some numbers and seeing what we get. We know that there are different numbers that add to 10. There's 5, 5, 6, 4, 7, 3, 8, 2, 9, 1, even 10, 0. It seems like we can have pretty much any number here. But let's think about it this way. If we have, let's say, all this A, B, C, and D, we know that 10 plus B has to equal A. A plus C has to equal B. And B plus D has to equal C. And C plus 3 has to equal D. Okay, so essentially we want to find A first of all here. Well, 10 plus B is equal to A, so A plus C is equal to B. We can kind of create like a system here and plug in numbers continuously. So this one changes to A equals B minus C, which we can put in right here. We get 10 plus B equals B minus C, which is also the same thing as 10 equals negative C, or C equals negative 10. I think I did that right. So we have C right here equals a negative 10. Now if C equals negative 10, then we can continue on with our system here. We have C equals negative 10, so B plus D equals negative 10. And C here, we can also substitute a negative 10 to get negative 10 plus 3 equals D, so D equals negative 7. So we can put that in here as well. Now we can solve for B2 because we know B plus negative 7 has to be negative 10, so B has to be negative 3. And 10 minus 3 has to be A, so A is 7. We know that this number plus 7 has to equal 10, so it's a 3. This number here plus 10 has to equal 3, so we have a negative 7. This number plus 3 has to equal negative 7, so we have a negative 10. This number minus 7 has to equal negative 10. We have a negative 3. And then x minus 10 has to equal negative 3. So x is equal to 7 for option B. Looks like that's what most people are getting to. So that took a little bit, then a couple of seconds there to solve that problem. But I think we got it. And yes, the answer is B. Great job to everyone that solved that one because that one was really interesting. It took a couple of seconds to get through.
I think that was a
Great.
great question to end it on. I think that was my favorite question out of all of them. It was pretty cool. But I think what you've all been waiting for is who gets those super cool Math Kangaroo prizes that were mentioned at the beginning. So I think we had a kangaroo plush, a kangaroo Lego puzzle, and a Math Kangaroo playing cards to the three most active students. Ryan, would you like to announce who those are?
Yeah. All right. So first, the winner of Kangaroo Plush. Kangaroo Plush will go to Y Zhu for being the most active in our chat today. So congratulations for the Kangaroo Plush. Next, we are going to give the Kangaroo Lego set or puzzle. And the winner of that is going to be Colette. Colette, you get the Lego set and the puzzle. And finally, one last one. Kangaroo playing cards. Our last and third winner for today, little drum roll, is Monil. All right. Congratulations to our three winners today. But everyone honestly is a winner because we solved all of these problems from Kangaroo Math and really hopefully had some fun on this Pi Day.
And for those of you who won, we have written your names down. And please email this email that I am writing up here. I think this is right. info.mathkangaroo.org or info@mathkangaroo.org. Email them to claim your gift, and we will remember who you are. So include your name in the email or the names that are on Ryan's screen in case it's just like a Zoom code name, super secret or something. Okay, congratulations, everyone. We really enjoyed
Yeah,
your participation here.
yep. Hopefully everyone has a great rest of their pie day and maybe enjoys it by eating a pie or two.